snt-networks. In today's video, we'll be talking about NAT along with IPSec. So usually we have an idea about IPSec, correct? We know how IPSec works with the main mode, quick mode, aggressive mode, right? Like AV2, like AV1 works, right? But there's a minor thing that we often are confused about, correct? That is natting in IPSec. We are always confused about this part. Like if somebody, in an interview or if you're working on some technology, correct? Then if you get asked about some, detailed questions on this, you tend to get a bit confused, correct? Like if, you're asked, you have an IPsec tunnel, correct? In that tunnel, why do we use netting? Okay. Then, uh, why NAT? First question they'll ask. Then they'll ask, how will it work? Correct? Then you need to know if it works, it usually uses port 4500 UDP, correct? Why do we use it? Correct. So these are three questions which are often asked, correct? And these are three questions which you need to have in mind while you're configuring or troubleshooting any sort of IPsec VPN, correct? Because NAT will be an important part of your network. Because if you're creating a site-to-site tunnel, consider this is site A, this is site B, correct? So there will be underlay, there will be a lot of devices, correct, which will have NAT among them. You're just creating a tunnel over it, right? The overlay is IPsec tunnel. The underlay could be anything, like it could be OSP, FVGP, whatnot, correct? Because there will be a lot of devices here. If this supports NAT, then you need to support NAT. So let's go with the overview, and we'll go out over this question, then we'll try to explain it in detail of and which will help you not just ace your interview, which will help you get strong understanding on the concepts as well. Like considering you have this small network. Okay, let's just create a small network first for basic understanding. This is the internet. So if you're trying to access anything from the internet, okay, you're trying to watch YouTube, you're trying to access something. Now what happens is when your packet is here, right, it will have source, it will have a certain, IP addresses, and like how the packet flows, right? So in the headers, you will have source IP, its own IP, correct? Let's just say it A and B. Source IP, its own IP. Okay, my bad. A. Destination IP will be whatever destination you're trying to reach to. Let's just say this is your server is C, correct? Source MAC address, it will be your X, Y, and Z. Okay, let me just use some different color so it's clear for understanding X, Y, and Z. So source MAC is X. Destination MAC in your case will be target MAC will be Y, correct? And the backup when the packet comes here, the source IP address again here will be A. Source IP address will be A. Destination IP address will be C. Source MAC will be Y because it changes per hop. Destination MAC address will be what? Destination MAC address will be, let's just say the next hop, whatever it is, right? V. So we'll use V. Okay, but when the packet is going outside, when it's going outside, this will not be A. We'll use the exit interface IP, which will be your, usually what you do is, what's my IP? You do that, your public IP. It will use your public IP. Let's just say public IP is M, capital M. So it will use M here. Rest parameters will be same, Y and Z. Okay. So this is how your traffic will flow. So what happened here? We just changed our IP to public IP. Why? That is called NAT. You cannot send packets out of your network using your private IPs. Correct? You need to use your public IP. That is also will be mapped to your egress interface, this interface. Okay? So we use that. Same goes here. If you're sending packets out, so what happens is your IP changed, right? From A to M. It changed. Correct? Now similarly in IPsec, what happens? Let me just wipe this off. So in IPsec, what happens? In IPsec, we say that we use a particular set of IP address plus we use integrity checks to make sure the packet has come from the right source. We do that. Now, how do we do the integrity checks? We use the hashing, correct? So once you are using hashing, you create a hash here using source IP, destination IP, correct? These headers you create a hash and you send it here. Correct. Now, if there is a natting device in between, what did I tell you? The IP changes from A to M, just for example. So per hop it will change. So once it has changed, it reaches B. So he B also calculates the hash of the packet. Correct. And the hash is here. Will the hash B also calculated a hash? Will the hash match? No. Why? Because initially there was a packet here which was hashed at A and the same hash, and we calculated a hash after a lot of hops. After a lot of hops, what happened? The value changed. So hash value changed. Correct. So now B says that no, 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 I cannot trust this connection because it came from a different source. This is not my source. Got it? So this is why we need natting to make sure that the integrity is in place, plus to make sure that if any value changes, correct, we can accommodate it because in real world the value will change. Okay. Now, why again this part is done. Why do we use natting? To make sure when the packet comes from the right source, it is accepted as it is. How it works? Now, how does it work? It works by see. Uh, so what happens is we have two modes, AH and ESP. Now, if we don't use NAT, like I told you, the value will change, and integrity will not be there. Correct. Now, the way natting works is after the packets, the whole packets. Correct. Like for ESP, what do we say? We say that this is the data, correct? This is your TCP, this is your IP, this is your ESP, correct? This is your IP. I'm talking about tunnel mode, okay? So this is your outer, this is your original one. This is your outer, this thing, what do you call? IP header. Now you will use UDP, UDP 4500 to encapsulate the whole packet. This whole packet will be encapsulated. Now here you can change whatever value you want. You want to change IP, you want to change whatever. Similarly for transport mode, you have data, you have TCP, correct? You have ESP, you have IP, okay? And then you have UDP 4500 with all ports. Now here what happens is the source and destination port will be both 4500, okay? Source port, destination port, both will be 4500, okay? So because of this, what happens is, this is again helped by NAT-T, by the way. NAT traversal. NAT traversal is sort of an extension or module of IPsec, which will help you, come across challenges of NAT-T, which will help you basically enable the UDP 4500. So again, just for clarity, so this is how it is done. Now, if you change anything here, doesn't matter. Okay, because this packets will be removed when it reaches the destination and only this will be checked. Here you see right IP address, right, ESP, session ID, everything will be same. Okay, so I hope this is clear. How it works is clear. Now, another thing at the same time, where it works, correct? So we have first two message hello will be there. This is talking about main mode. Okay, so first two message exchange will be, you just send your payloads, correct? You send your keys, your payloads. I mean, not keys. You send your cryptographics, right? You send your encryption authentication algorithms, correct? Then in third and fourth, you have key and nonce, correct? Fifth and sixth will be identity and hash, correct? That is the reason we say fifth and sixth will be encrypted because key is already generated, correct? Key is already generated there. Now with NAT, how it works? The first two message exchanges, you will see if NAT-T is turned on or not. If NAT-T is turned on in A and NAT-T is turned on in B. So you can see in the Wireshark, you will be able to see both of them. So if NAT-T is turned on, you support natting, correct? In next two message exchanges, you will see about NAT-D. So we say that, okay, NAT-D is there, we support NAT, but we also need to check if there is any NATing device in between, correct? We also need to check that. For that, we use NAT-D. NAT-D is NAT discovery. So how it works is you create a packet, you take a hash of it, just like told you, right? The value changes. So we take a hash of it, of source IP, destination, excuse me, source IP, source port, destination IP, and destination port, and you send the packet across. So once you send the packet across, you take a hash of it and you send the packet. So it gets two values, the packet and the hash. It also will create a hash here of the same packet. And if both the hash value matches, there is no netting device. If it doesn't match, because there is no encapsulation in this part, right? We're just checking if there is a netting device in between. If the hash doesn't match, then we confirm that there is NAT. Okay. And finally, once this is done, we use port UDP 4500 to encapsulate the packet and then send it. So here the actual natting happens. First two messages NAT-T, first two messages NAT3, third and fourth NAT-D, fifth and sixth UDP NAT. Okay, finally NAT will happen. So, some of you will ask basically why UDP 4500 is globally recognized. Correct. Uh, it is reserved by NAT-T, correct, and all the natting devices in between will by default allow it. Using port 45, correct, without interfering the encrypted payload. And it's again a global standardization of UDP 4500. So this is basically how the NAT part works in IPSec. I think this is also clear. And if you have any other questions, any other doubts, or if you want me to talk about anything else, please do let me know, and we'll make sure to go in detail and tell you and show you how it works. I hope this was helpful. Thank you.